So I have one of the filters set up that you're going to be exploring with in this lab. And what I'm doing is on the top row right here, I'm providing the sinusoidal signal. On the bottom is my ground. So this is my input going to the inductor. This red probe right here is reading off that, and then finally it goes back to ground through this resistor. So here's my function generator. Here's my oscilloscope, and I've zoomed in very nicely on the wave. Now, if you go over to source, there's different ways that you can trigger your oscilloscope. You have channel 1, channel 2, and external. One thing that'll make your life a lot easier is if you trigger externally, what you can do is you can, your function generator generates a pulse. So basically you want to take a BNC to BNC cable and connect it from sync to external trigger. What this guy does is it creates a clock that is fed to this guy and tells this guy when to sync up, versus if I change to trigger source 1 or 2, it's looking for a particular voltage and is trying to trigger off that voltage. So if I put it back to 1 here, I try going in a lot smaller, it's having a little bit of trouble triggering. As you notice, it's kind of flaking around. So let me zoom out again. So I have the whole wave. I'm going to change it to external source. I'm going to put this as close as I can to 0. And now what I'm going to do is I'm going to zoom in. And it's still having, oops, it's being a little flaky. Sometimes the voltage per division is a little flaky. So now we have our two waves here. Now how am I going to measure the time difference between these for my delta? Well, first I need to know which channel is which. So if I press 1, it'll turn off the wave that's 1. So I know that this bottom guy is 1, and I know this top guy is 2. So if I go to cursor, and I select T1, so right here, this is T1, and I move T1 over to where it crosses the 0, which is right about here, and I press T2, and I move to where it crosses 0, which is about there. In this bottom right, I get 1 over delta T, and then right next to it is delta T, which is in microseconds here. In this case, this is 90 microseconds. So that's how you do a delta T measurement.